All right, let's talk about something that every single Python developer runs into: organizing your code. We're going to look at how you can go from a complete mess to a masterpiece. Let's dive in.
Okay, be honest. You've been there, right? You start a project, it's just this tiny little script, but then it grows, and it keeps growing, and suddenly you're scrolling through one single giant file, just trying to find that one function you wrote last week. It's like trying to untangle a giant pair of headphones from the bottom of your backpack.
Well, that feeling, it has a name. We call it spaghetti code. And it's exactly what it sounds like. This tangled mess where everything is just dumped into one huge file. I mean, sure, it might work, but the second you have to fix a bug or add something new, it's a total nightmare. Trust me, it's a rite of passage for every coder.
But what if you could take that junk drawer of code and turn it into a perfectly organized toolbox? You know, where every single tool has its own dedicated spot. You can find it in a second, and it's ready to go. That is what we're aiming for today.
And the way we do that is with a technique called modular programming. The whole idea is simple. You break down a big program into smaller, independent, and reusable parts. Think of them like Lego bricks, or, well, the tools in our toolbox. This is the secret sauce that turns simple scripts into seriously powerful software.
Okay, so how do we actually do this? It might sound complicated, but honestly, it all boils down to two really simple ideas: modules and packages. These are your building blocks. They're what we're going to use to build that awesome, organized toolbox.
Let's start with the most basic piece, the module. So what's a module? It's a file with Python code in it. Seriously, that's it. Any file you save with the .py ending, that's a module. No magic here. If you've ever written a Python script, congratulations, you've already made a module. And using them is just as easy. It's literally 2 steps. Step 1, create your module. Just write your functions in a file, say mymath.py. Step 2, use it. In whatever other file needs those functions, you just type import mymath. Boom, done. All that code is now ready to use in your second file.
Now, Python actually gives you a few options for how to import your code, and each one's good for different situations. You can import the whole module, that's the standard way, keeps everything nice and neat. Or you can just grab one specific function if that's all you need. And my favorite, you can give a module an alias, a nickname, which is amazing for shortening those super long module names.
All right, you have definitely seen this weird line of code before. If ___ name equals ___ main. It looks kind of confusing, right? But it's actually a super clever trick. Here's the deal. Every Python file has this special built-in variable called ___ name. When you run that file directly from the command line, Python sets ___ name to be ___ main. But if you import that file into another one, ___ name gets set to the module's actual file name. So what does this let you do? It lets you write a chunk of code that only runs when you execute the file directly. It's perfect for things like running tests or showing a quick example of how your module works.
Okay, so modules are awesome. We're breaking our code into separate files. But what happens when your project gets bigger and now you have like dozens of these module files? Your folder can start looking pretty messy all over again. It's time to level up our organization game. And that brings us to the next level: packages. So what's a package? It's just a folder that you use to group related modules together. Think of it like this. In your toolbox, you don't just throw everything in one big pile. You have a drawer for screwdrivers, another for wrenches. A package is just like one of those drawers. It's all about creating that next level of structure. There is one little special requirement, though. For a folder to be a package, it needs to have a file inside called __init.py. And the funny thing is, most of the time, this file is completely empty. Its only job is to exist. Just by being there, it signals to Python, hey, this isn't just any old folder. This is a package. Pay attention. It's so simple, but it's what makes the whole system work. So we've covered the how, right? We make modules, we group them into packages. But let's get to the really important part, the why. Why bother with all this? What's the actual payoff? This is where things get really cool. And let's be clear, this is about way more than just keeping your files tidy. This idea of modular design, it is the bedrock of how almost all professional, large-scale software is built. It's the blueprint that lets huge teams of developers work together on massive, complex projects without stepping on each other's toes.
Let's look at a real-world example you've probably heard of. If you've ever touched data science or scientific computing in Python, you know NumPy. It's this enormous, critical library, and guess what? It's a masterclass in modular design.
The way NumPy is built is a perfect example of this. It's one giant package, but it's filled with specialized submodules. If you need to do linear algebra, you don't import all of NumPy. You just import numpy.linog. If you need to generate random numbers, you grab numpy.random. It's like going to that toolbox and only pulling out the exact wrench you need, which keeps your code fast and clean.
And it's not just for data science. Let's jump over to a totally different world, web development. You've got Django, right? One of the biggest Python web frameworks out there, famous for letting people build stuff incredibly fast. And what's its secret weapon? You already know, it's modularity.
Django's whole philosophy is built around these reusable apps. Each app is its own self-contained module or package that does one specific job, like handling user logins or running a blog. The beautiful part is, you can build a user authentication app for one website and then just drop it into your next project. It's all about reusing your work and building things way, way faster.
So look at that. We started with the problem of tangled spaghetti code. We found the solution with modules and packages, and we've seen how the biggest names in the Python world use these ideas to build amazing things. This isn't just another technique to learn. This is a genuine superpower for your coding. When it all comes down to it, this is about moving from chaos to clarity. It's about writing code once and using it everywhere. It's about organizing your projects so they make sense. It means you can find and fix bugs so much faster. And the best part? It gives you the confidence to build bigger, more ambitious things without creating a giant mess. So, I'll just leave you with this thought. You now have the building blocks for creating clean, scalable, powerful software. You know how to build with Legos instead of a pile of spaghetti. The only question now is, what are you going to build?